Oberst Heinrich Weber stood motionless on the fog-shrouded pier in Oakland, California, his weathered hands gripping a pair of Zeiss binoculars so tightly that his knuckles turned white against the cold Pacific morning of March 15, 1943. The salt air carried the acrid smell of welding smoke and hot steel as he adjusted the precision German lenses with trembling fingers. Through the clearing mist, he watched something that defied every principle of shipbuilding he had learned. During 25 years of distinguished naval intelligence service under 3 different German administrations, before him stretched an industrial nightmare that seemed torn from the pages of American science fiction. Dozens of massive cargo ships in various stages of construction, rising simultaneously from assembly bays that operated around the clock like mechanical heartbeats pounding against the rhythm of war itself. The Richmond shipyard, one of Henry Kaiser's revolutionary facilities, sprawled across 1,500 acres of what had been empty California farmland just 18 months earlier. Now it housed the largest shipbuilding operation in human history, employing over 100,000 workers in facilities that produced complete 10,000-ton cargo vessels faster than German craftsmen could build rowboats. The sound was overwhelming and utterly alien to Weber's European sensibilities. Thousands of pneumatic hammers driving rivets into steel plates with staccato rhythms that echoed across San Francisco Bay. Welding torches hissing as they fused metal with brilliant blue flames that painted strange shadows on the morning fog. Massive cranes groaning under the weight of prefabricated ship sections that moved through the air like building blocks in the hands of giant children playing with toys that weighed hundreds of tons. But it was the impossible speed of construction that made Weber's professionally trained mind reel with disbelief and growing horror. Through his binoculars, he could see workers swarming over hull sections that had been empty steel frameworks just days earlier. Entire ship superstructures were being lifted into place by cranes that operated with the precision of Swiss clockwork but the power of industrial earthquakes. "Mein Gott im Himmel," he whispered in his native German, his voice lost in the thunderous cacophony of American industrial power unleashed. "They are launching ships faster than our U-boats can sink them, faster than we ever dreamed possible." Weber lowered his binoculars and consulted the small leather notebook where he had been recording observations with the meticulous attention to detail that had made him one of Germany's most respected intelligence officers. The numbers seemed impossible, yet his own eyes confirmed what his training told him could not exist. Liberty ship hull number 440 had been launched yesterday after just 38 days of construction. Hull 441 was scheduled for launching next week, 35 days after her keel laying. Hull 442 was already taking shape in ways that suggested completion in fewer than 30 days. The mathematical implications were staggering and strategically catastrophic for German naval planning. At this single facility alone, American workers were producing 1 complete cargo ship every 10 days on average, with some vessels completed in periods that German shipyards would require for preliminary design work. Multiplied across the dozens of American shipyards that intelligence reports suggested were operating at similar pace, American cargo capacity was increasing at rates that made German submarine warfare not just ineffective, but strategically meaningless. Just 18 months earlier, in the oak-paneled conference rooms of German Naval Intelligence Headquarters on Tirpitzufer in Berlin, Weber and his distinguished colleagues had shared contemptuous laughter over intercepted American shipbuilding plans that claimed the United States could produce cargo vessels at rates that violated every known principle of naval construction developed over centuries of European maritime experience. The Liberty ship program, they had declared with the absolute certainty of professionals who understood the complexities of maritime engineering, was typical American propaganda, fantastical claims designed to boost civilian morale while disguising the fundamental reality that democratic capitalism could never match the focused efficiency and superior organization of National Socialist industrial management. "Examine these absurd specifications," Kapitän zur See Friedrich Ruger had said, with the measured disdain of a man whose family had served in German naval forces for 4 generations, spreading captured American planning documents across the mahogany table, where German admirals had meticulously planned the U-boat campaign that would strangle Britain's maritime lifelines and force Churchill's government to sue for peace before American industrial potential could be fully mobilized. The conference room itself embodied centuries of German naval tradition. Oil paintings of victorious admirals from the Imperial Navy decorated walls paneled in wood taken from captured French warships, while the massive table had been crafted from timber salvaged from British vessels sunk during the previous war. Every detail reinforced German confidence in maritime superiority and professional competence that had dominated European waters for generations. The Americans claim they will mass-produce 10,000-ton cargo ships using welded construction methods and prefabricated section assembly, completing entire vessels in fewer than 60 days from keel laying to delivery, Rouge continued, his voice carrying the professional skepticism of a man who had overseen construction of German naval vessels that required years to complete using traditional methods handed down through generations of master shipwrights. This is not shipbuilding as civilized nations understand the art. This is American industrial fantasy designed to convince their British allies that adequate aid will continue flowing across the Atlantic despite our U-boat campaign. The assembled intelligence officers had nodded in grave professional agreement, their gold braid and oak leaves reflecting decades of naval expertise and intimate knowledge of shipyard capabilities throughout Europe and the Americas. These men had studied American industrial capacity extensively, visited American ports during peacetime, and interviewed German technical experts who had worked in American industries during the 1930s. Their assessments were based on solid professional knowledge and careful analysis, rather than wishful thinking or propaganda-influenced assumptions. Vice Admiral Karl Dönitz, architect of Germany's revolutionary submarine warfare strategy and the officer who would soon command all German naval forces, had dismissed the Liberty ship program with the characteristic precision that had made him the Reich's foremost expert on maritime warfare. American shipyards have never demonstrated capacity for mass production of large vessels using industrial methods. Their construction techniques remain rooted in individual craftsmanship and custom construction approaches that prioritize aesthetic qualities over production efficiency. Even if they possess the theoretical ability to build ships at the claimed rates, which violates basic principles of metallurgy and marine engineering, they categorically lack the steel allocation, skilled labor pool, and logistical coordination capabilities necessary for sustained production at wartime scales. Dönitz had gestured toward detailed charts showing American steel production, shipyard capacity, and skilled worker availability that seemed to support German conclusions about American limitations. Furthermore, their welded construction methods are inherently inferior to proper riveted techniques used by serious maritime nations. Welded hulls suffer from structural weaknesses that make them unsuitable for North Atlantic service conditions. American workers, trained in simplified assembly tasks rather than comprehensive shipbuilding crafts, cannot possibly produce vessels capable of surviving the stress conditions they will encounter in combat zones and severe weather operations. The German assessment appeared professionally sound and strategically reassuring. American shipbuilding capacity seemed adequate for peacetime commercial requirements, but completely inadequate for the massive merchant marine expansion that would be necessary to sustain Britain through prolonged submarine blockade while simultaneously supporting American military operations in multiple theaters across the globe. How catastrophically wrong the German assessment proved to be. By March 1945, exactly 2 years after Weber's shocking reconnaissance of Kaiser's Richmond facility, American shipyards had not just built cargo ships, they had revolutionized naval construction itself, creating an industrial tsunami that would ultimately deliver 2,611 Liberty ships to Allied forces, each vessel capable of carrying 10,000 tons of cargo across oceans that German submarines could no longer effectively patrol due to overwhelming Allied escort strength and rapidly improving anti-submarine technology. The numbers told a story that German intelligence had failed to comprehend and refused to accept until evidence became so overwhelming that denial was impossible. One Liberty ship launched every single day for over 4 consecutive years, a pace of construction that exceeded the combined shipbuilding capacity of every other maritime nation in human history, by margins that seemed to mock traditional understanding of industrial limitations and resource constraints. But these raw statistics represented only the surface manifestation of a deeper transformation that challenged fundamental assumptions about what democratic societies could accomplish when their survival depended on industrial mobilization of unprecedented scope and intensity. The Liberty ship program wasn't merely about building cargo vessels using improved techniques. It was about applying American mass production genius, developed through decades of automotive and consumer goods manufacturing, to the ancient art of shipbuilding in ways that created capabilities no traditional maritime power could match, anticipate, or even imagine as theoretically possible. The story begins in the increasingly desperate days of 1940, when Britain faced systematic strangulation by German U-boats that were sinking merchant vessels at rates far exceeding British shipyard capacity to replace losses, creating a maritime crisis that threatened to force Churchill's government out of the war long before American military strength could be brought to bear against Nazi Germany. Prime Minister Winston Churchill, understanding with crystal clarity that Britain's survival as an independent nation depended absolutely on maintaining supply lines across the Atlantic Ocean, had appealed directly and urgently to President Franklin Roosevelt for American shipbuilding assistance that could offset the mounting shipping losses to German submarine warfare. The strategic mathematics were stark and becoming more unfavorable each month. German U-boats were sinking Allied merchant vessels at average rates exceeding 500,000 tons monthly during 1940 and early 1941, while British shipyards could replace barely 200,000 tons of shipping capacity during the same periods. The gap was widening rather than narrowing as German submarine construction accelerated and U-boat tactics improved through combat experience, while British shipyard capacity remained constrained by traditional construction methods, limited steel allocation, and workforce shortages caused by military conscription. The challenge facing potential American intervention was enormous and unprecedented in the entire history of naval construction. Britain needed not just additional ships, but massive numbers of standardized cargo vessels, produced quickly enough to stay ahead of German sinking rates while carrying sufficient cargo capacity to sustain a nation under siege that had become completely dependent on imported food, raw materials, fuel, and military supplies from across the Atlantic. Traditional shipbuilding methods, which emphasized individual craftsmanship, custom design solutions, and construction techniques that had remained essentially unchanged since the age of sail, were completely inadequate for wartime requirements that demanded hundreds of identical vessels produced simultaneously, rather than dozens of unique ships built sequentially over extended periods measured in years rather than months. American maritime industry in 1940 was surprisingly small, geographically scattered, and oriented toward peacetime commercial requirements that bore no resemblance to the wartime emergency production scales that would be necessary to make meaningful impact on the Battle of the Atlantic. The entire American shipbuilding establishment employed fewer than 100,000 workers in facilities designed primarily for constructing luxury passenger liners, specialized cargo vessels for specific trade routes, and naval warships that required 2 to 4 years to complete using traditional construction methods that had been handed down through generations of maritime craftsmen. The existing American shipyards, while capable of producing excellent individual vessels, operated according to principles that made mass production impossible under any circumstances. Each ship was essentially a custom project requiring unique design solutions, specialized materials, and skilled craftsmen who understood every aspect of maritime construction, from hull design through propulsion systems to navigation equipment installation. Henry J. Kaiser, a California industrialist whose background in large-scale construction projects and dam building had given him extensive expertise in project management, logistics coordination, and industrial organization, but absolutely no experience in shipbuilding or maritime engineering, proposed a revolutionary approach that seemed to violate every established principle of naval construction. Design a single standardized cargo ship design, simple enough to build using prefabricated components, manufactured in separate facilities, then construct multiple new shipyards specifically designed for rapid assembly of identical vessels using workers trained in highly specialized tasks rather than traditional maritime crafts. Kaiser's concept was audacious to the point of seeming impossible to maritime professionals who understood the complexities of shipbuilding. Instead of building ships as individual projects requiring years of skilled craftsmanship, he proposed treating cargo vessels like automotive products that could be manufactured using assembly line techniques, standardized components, and semi-skilled workers who could be trained in specific tasks within weeks rather than years. The Maritime Commission, created by Congress to oversee American merchant marine development and desperately searching for solutions to Britain's shipping crisis, awarded Kaiser preliminary contracts for building Liberty ships using his untested industrial methods, despite strong opposition from traditional shipbuilders who represented centuries of accumulated maritime expertise and professional knowledge. Established shipbuilding firms, representing the finest traditions of American maritime craftsmanship and technical excellence, predicted catastrophic failure and warned that mass-produced ships would break apart in heavy seas, suffer structural failures under normal loading conditions, or experience mechanical breakdowns that would result in massive loss of life and cargo. The opposition was not based on professional jealousy or resistance to change, but on genuine technical concerns about applying industrial mass production methods to maritime construction that required precision engineering and structural integrity under the most demanding environmental conditions imaginable. Rear Admiral Emery Scott Land, chairman of the Maritime Commission and a distinguished naval architect whose career had included designing some of America's finest naval vessels, defended the Liberty ship program against intense criticism from traditional shipbuilders with arguments that emphasized practical necessity over theoretical perfection. We are not attempting to build the most beautiful ships ever designed, the fastest vessels ever launched, or the most sophisticated cargo carriers ever conceived by maritime architects. We are trying to build adequate ships in sufficient numbers to win a war against an enemy that understands the strategic importance of maritime logistics. Perfection is the enemy of production, and production capacity is what will ultimately determine victory or defeat in the Battle of the Atlantic. Land's arguments reflected hard strategic realities that trumped traditional maritime aesthetics and professional preferences. The war would be won or lost based on logistics capacity rather than individual vessel excellence, and logistics capacity required numbers of ships that could only be achieved through revolutionary approaches to maritime construction that abandoned traditional methods in favor of mass production techniques adapted from other industries. Meanwhile, German intelligence services were systematically monitoring American shipbuilding activities through extensive networks of agents, diplomatic observers, sympathizers, and neutral country sources who provided regular detailed reports on American industrial capabilities, production planning, facility construction, and workforce development. These intelligence assessments, compiled by professional analysts with extensive knowledge of maritime engineering and industrial organization, consistently concluded that American shipbuilding claims were either impossible propaganda designed to maintain Allied morale or evidence of American industrial confusion that would ultimately result in catastrophic waste of resources and strategic failure. Oberst Heinrich Weber, one of Germany's most experienced and respected naval intelligence officers, had spent 3 productive years in the United States during the mid-1930s while serving as assistant naval attaché at the German embassy in Washington, D.C. His assignment had included comprehensive study of American industrial capabilities, visits to major manufacturing facilities, interviews with industry leaders, and detailed analysis of American shipyard operations, steel production capacity, and technological development programs. Weber's extensive reports, highly regarded by German Naval Command and frequently cited in strategic planning documents, provided what appeared to be authoritative assessments of American shipyard facilities, workforce capabilities, steel allocation systems, and industrial organizational methods that seemed to validate German assumptions about fundamental American limitations in maritime construction and mass production coordination. American shipbuilding remains primarily oriented toward peacetime commercial requirements and luxury passenger service, Weber had written in his comprehensive 1939 assessment that became the foundation for German strategic planning regarding American industrial potential. Their largest and most capable facilities are designed for constructing passenger liners and specialized cargo vessels using traditional construction methods that require extensively skilled craftsmen and extended construction periods measured in years rather than months. They demonstrate no understanding of the coordination, resource allocation, and systematic organization necessary for sustained wartime construction programs operating at the scales that would be required to influence major naval campaigns. Weber's analysis, based on extensive visits to major American shipyards, detailed interviews with American industry leaders, and careful observation of American industrial methods, seemed professionally comprehensive and strategically reliable. The assessment concluded that American shipbuilding capacity was adequate for normal peacetime commercial requirements, but could never expand rapidly enough or operate efficiently enough to replace British shipping losses at the rates that German submarines were capable of inflicting, using improved tactics and increased boat availability. The analysis appeared to be validated by American shipbuilding performance during World War I, when American yards had struggled to meet wartime production targets and had required extensive British technical assistance to produce vessels of acceptable quality for military service. German planners, familiar with the difficulties American shipyards had encountered during the previous conflict, assumed that American industrial organization had not improved significantly during the intervening decades. The first Liberty ship, SS Patrick Henry, was launched with great fanfare in Baltimore on September 27, 1941, just 14 days after her keel was laid, a construction speed that seemed physically impossible to German observers monitoring American activities through intelligence networks and public press reports. The achievement appeared to violate basic principles of metallurgy, structural engineering, and quality control that governed all serious shipbuilding operations throughout maritime history. German analysts initially dismissed the Patrick Henry launching as an obvious propaganda stunt, involving either a partially pre-built vessel that had been secretly under construction for months, or grossly exaggerated timeline claims designed to impress British officials and boost American public opinion during a period when American entry into the war remained politically uncertain and controversial. But the Patrick Henry was followed by additional Liberty ships completed in periods that continued to violate every known principle of naval construction according to European maritime expertise. The SS Robert E. Peary was built in an incredible 4 days and 15 hours as a dramatic demonstration of American industrial potential and shipyard efficiency. Though this record-breaking achievement involved extensive preparation, pre-positioning of materials, and specialized crew assignments that made it more of an industrial exhibition than normal production procedure. However, even normal Liberty ship construction was averaging 42 days from keel laying to launching during peak production periods in 1943 and 1944, representing construction speeds that were 3 to 4 times faster than the best European shipyards could achieve under ideal conditions, using their finest craftsmen and most advanced techniques. Kaiser's Richmond shipyard in California became the epicenter of this industrial revolution, ultimately employing over 100,000 workers in facilities that operated continuously around the clock, using techniques carefully adapted from automotive manufacturing, construction industries, and other mass production systems that had been developed during the previous decades of American industrial growth. The scale of the Richmond operation defied European understanding of shipyard organization and workforce management. The facility sprawled across 1,500 acres of land that had been agricultural fields just months earlier, now transformed into the largest shipbuilding complex in human history. 4 separate building ways allowed simultaneous construction of multiple vessels, while extensive prefabrication shops manufactured ship sections that were transported to assembly areas by specially designed cranes and railway systems. Workers with absolutely no previous shipbuilding experience were recruited from farms, stores, offices, and homes across America, then trained in highly specialized tasks, welding specific types of joints, installing particular systems, assembling designated components, that allowed rapid ship construction without requiring traditional maritime crafts knowledge that took years to develop and master. The training programs developed for Liberty ship construction were revolutionary in their scope and effectiveness. Women who had been teachers, secretaries, store clerks, and housewives learned to operate massive cranes, perform precision welding, and install complex marine systems within weeks of starting their shipyard employment. Men who had been farmers, mechanics, and laborers became experts in prefabrication techniques, hull assembly, and propulsion system installation using methods that had been developed specifically for mass production rather than traditional craftsmanship. The prefabrication techniques developed for Liberty ship construction represented a fundamental departure from traditional shipbuilding methods that had remained essentially unchanged since wooden sailing ships had given way to iron and steel vessels during the 19th century. Instead of building ships sequentially from keel to completion using traditional staging methods, American yards manufactured major structural sections in parallel assembly processes, then moved completed sections to building ways for final assembly and launching. Entire ship sections, bow assemblies weighing hundreds of tons, stern sections including propulsion systems, midship cargo holds with complete structural framing, superstructure components including bridge and crew quarters, were manufactured in specialized shops using mass production techniques, then transported to assembly areas where they were welded together to form complete vessels ready for launching and final outfitting. The process resembled automotive assembly lines more than traditional shipyards, with standardized components moving through predetermined stages of completion rather than individual craftsmen working on unique vessels from initial design through final delivery. Quality control was maintained through systematic inspection procedures and standardized specifications rather than relying on the individual expertise and professional reputation of master craftsmen. German intelligence services, monitoring American shipbuilding developments through various sources including neutral country observers and intercepted American communications, initially interpreted these revolutionary methods as evidence of American industrial confusion and lack of understanding about proper maritime construction techniques, rather than recognition of genuine innovation that could fundamentally change the nature of shipbuilding. Traditional German shipbuilding expertise, developed through centuries of maritime experience and refined through extensive wartime construction programs, suggested that welded construction was inherently inferior to properly riveted methods, that mass production techniques could not provide the quality control and structural integrity necessary for seaworthy vessels, and that workers without extensive maritime training could never produce reliable ships capable of surviving North Atlantic service conditions. Captain Hermann Densch, chief of German naval construction and one of Europe's most distinguished experts in traditional shipbuilding methods, reviewed American Liberty ship reports with the professional skepticism that reflected centuries of accumulated European maritime experience and technical knowledge. Welded hull construction is inherently weak and prone to catastrophic structural failure under the stress conditions commonly encountered in North Atlantic service, particularly during winter storm seasons. Mass production techniques, however efficient for manufacturing simple consumer goods, cannot provide the individual attention to detail and quality control that is absolutely essential for maritime construction. American workers, trained in simplified assembly tasks rather than comprehensive shipbuilding crafts, cannot possibly produce vessels capable of surviving the demanding service conditions they will encounter in combat zones and severe weather operations. Densch's concerns appeared to be validated by early reports of Liberty ship structural problems, including dramatic hull fractures that occurred when some vessels encountered severe weather or heavy loading conditions. Several Liberty ships suffered catastrophic hull failures that resulted in complete loss of vessel and cargo, seemingly confirming German predictions about the dangers of mass production applied to maritime construction. However, German analysts failed to recognize that American industrial methods included systematic approaches to identifying and correcting production problems that traditional craftsmanship methods could not match in terms of speed and effectiveness. When Liberty ship hull fractures were identified as problems related to steel specifications and welding procedures, American engineers rapidly developed improved materials and techniques that eliminated the structural problems while maintaining production speed and efficiency. The continuous improvement processes built into American mass production systems allowed rapid implementation of technical solutions across thousands of vessels, while traditional shipbuilding methods would have required years to incorporate similar improvements into individual construction projects. By 1943, Liberty ship reliability had improved dramatically, while production rates continued to increase, demonstrating that mass production could achieve both quantity and quality when properly managed and continuously refined. German submarine commanders, initially skeptical of intelligence reports suggesting massive increases in American ship production capacity, began encountering growing numbers of Liberty ships in Atlantic convoy operations during 1942 and 1943. The vessels proved frustratingly difficult to sink completely due to their compartmentalized construction and simple structural design that often allowed them to remain afloat and operational even after torpedo attacks that would have destroyed more sophisticated ships with complex systems and elegant engineering. Kapitän-Leutnant Wolfgang Luth, one of Germany's most successful U-boat commanders and recipient of the Knight's Cross with oak leaves, swords, and diamonds, reported increasingly frequent encounters with Liberty ships that challenged fundamental German assumptions about American construction quality and vessel capabilities. These American cargo vessels are crude in appearance and lack the sophisticated engineering of properly designed merchant ships, but they demonstrate surprising resilience in combat situations and structural integrity under battle damage conditions. I have personally observed Liberty ships continuing to steam at reasonable speeds after torpedo hits that should have resulted in immediate catastrophic sinking. Their welded construction, while appearing inferior to traditional riveted methods preferred by serious maritime nations, seems to provide unexpected structural durability and damage resistance under actual combat conditions. The production statistics that had initially been dismissed as outrageous American propaganda became increasingly difficult for German intelligence services to ignore as multiple sources confirmed the extraordinary scale of American shipbuilding activities and the accelerating pace of Liberty ship construction across dozens of facilities operating simultaneously throughout the United States. By 1943, American shipyards were completing Liberty ships at average intervals of 42 days during normal production operations, with some facilities achieving construction times of fewer than 30 days and exceptional cases completed in under 2 weeks, when special efforts were made to demonstrate American industrial capabilities to Allied observers and neutral country representatives. Kaiser's Richmond facility alone was producing one complete Liberty ship every 10 days during peak production periods, employing workers who had been farmers, store clerks, housewives, teachers, and students just months earlier, but who had been transformed through intensive training programs into skilled shipbuilders, capable of constructing ocean-going vessels that would carry vital supplies across submarine-infested waters to every theater of global warfare. The transformation of American shipbuilding from traditional craft industry to mass production powerhouse occurred with breathtaking speed that seemed impossible to European observers accustomed to industrial changes that required years or decades to implement successfully. Entire shipyards were designed, constructed, equipped, staffed, and brought into production within periods that European shipbuilding industries would normally require for preliminary planning and design work on individual vessels. Rosie the Riveter became more than just a symbol of American women in wartime manufacturing. She was literally welding ship hulls in yards that operated around the clock, 7 days per week, creating an industrial rhythm that never paused for weather, holidays, or traditional work schedules. Women who had never seen ocean-going vessels before the war found themselves operating massive cranes that lifted 1,000-ton ship sections with precision that required months of training and practice to master safely and efficiently. Mary Catherine Miller, a former elementary school teacher from rural Kansas who had moved to California specifically to work in Kaiser's Richmond shipyard, captured the personal dimension of this industrial transformation in detailed letters to her family that were preserved and later donated to historical archives. "I am building ships now with my own hands, actually constructing ocean-going vessels that will carry food, weapons, and supplies to our boys fighting overseas and to our British allies who are holding the line against Hitler's forces. 6 months ago, I was teaching arithmetic and reading to farm children in a one-room schoolhouse, and now I am welding steel plates that will sail across dangerous waters where German submarines are waiting to sink anything that moves." Miller's letters document not just personal transformation, but the broader social revolution that Liberty ship construction created throughout American communities. The work is physically demanding, And the hours are long. We work 12-hour shifts 7 days per week. But every ship we finish represents a victory against Hitler's submarine campaign. We launch a new Liberty ship every few days from our facility alone, and each one represents thousands of tons of supplies that will reach Britain, Russia, and our forces in North Africa safely despite everything the Germans can do to stop them. The human stories behind Liberty ship production revealed the complete mobilization of American society for industrial warfare on scales that had never been attempted in human history. Men too old for military service worked alongside teenagers too young for the draft. Rural Americans who had never seen the ocean learned to build ships that would sail to every continent on Earth. Urban dwellers who had worked in peacetime industries requiring completely different skills adapted those abilities to maritime construction that differed radically from any previous American manufacturing experience. Women entered industrial work in numbers and roles that challenged traditional social expectations and created lasting changes in American employment patterns and gender roles. African Americans found employment opportunities in shipyards that had been closed to them in peacetime, contributing their skills and labor to vital wartime production while beginning to break down racial barriers that had limited their economic participation. The social transformation extended beyond shipyard employment to encompass entire communities that grew up around Liberty ship construction facilities. Towns that had been agricultural centers or small commercial communities found themselves hosting massive industrial operations that employed tens of thousands of workers, required extensive housing construction, and created entirely new local economies based on wartime production rather than traditional regional activities. Richmond, California, grew from a small town of 20,000 residents to a major industrial city of over 100,000 people within 2 years, as workers from throughout America moved to the West Coast to participate in Liberty ship construction. Similar transformations occurred in dozens of communities across the United States, where Liberty ship facilities were established, creating a network of industrial centers that had never existed before the war and would influence regional development for decades afterward. The logistical challenges of supporting Liberty ship construction were as revolutionary as the construction methods themselves. Raw materials, steel plates, structural components, propulsion systems, electrical equipment, navigation instruments had to be manufactured, transported, and delivered to shipyards operating at unprecedented production rates across thousands of miles of territory. The steel requirements alone strained American industrial capacity and required expansion of mining, smelting, and fabrication facilities throughout the United States. Each Liberty ship required approximately 2,500 tons of steel, fabricated into hundreds of different components, with precise specifications and delivery schedules that coordinated with construction schedules at dozens of shipyards operating simultaneously. Railroad systems were expanded and modified to handle the massive transportation requirements created by Liberty ship construction, with special cars designed for carrying prefabricated ship sections, dedicated freight schedules for shipyard supply, and new rail connections built to serve facilities that had been constructed in previously undeveloped areas. The coordination requirements were staggering and required development of management and communication systems that had never been attempted for industrial projects of such scope and complexity. Production schedules, material deliveries, workforce assignments, and quality control procedures had to be synchronized across hundreds of suppliers, dozens of shipyards, and thousands of individual components that came together to create completed vessels ready for immediate service in combat zones. German agents attempting to monitor and assess American shipbuilding activities found themselves completely overwhelmed by the scale and complexity of industrial operations that exceeded their ability to gather accurate intelligence using traditional espionage methods designed for monitoring conventional military production programs. Franz Joseph Clausen, a German-American businessman who had provided intelligence to German consulates before America's entry into the war, wrote increasingly urgent and detailed reports about American shipbuilding activities that his intelligence handlers initially dismissed as exaggeration, misinformation, or deliberate deception designed to mislead German strategic planning. The Americans are building ships using factory methods I have never seen applied to maritime construction in any country or during any historical period. Workers move from station to station, performing specialized tasks on identical vessels that progress through predetermined assembly stages, like automobiles moving through Detroit production lines. The speed is absolutely incredible. I have personally watched ships grow from steel plates to completed vessels in periods that our finest German shipyards would require for preliminary planning and design work alone. Clausen's reports documented construction methods that seemed to violate basic principles of shipbuilding as understood by European maritime experts. They use massive cranes to lift entire ship sections that have been prefabricated in separate facilities, then weld these sections together to create complete vessels. The welding is performed by workers who learned their skills in weeks rather than years, yet the quality appears adequate for ocean service. Most remarkably, they are achieving construction schedules that complete entire ships in periods shorter than our shipyards require to install propulsion systems in vessels already under construction. The psychological impact on German naval planning became increasingly severe, as U-boat commanders reported growing difficulty in sinking Allied shipping faster than American yards could replace losses, fundamentally undermining the strategic calculations that had justified Germany's submarine warfare campaign as a potentially decisive weapon for forcing Britain to negotiate peace before American military strength could be fully mobilized and deployed. Admiral Karl Dönitz, promoted to command all German naval forces and responsible for submarine strategy that was supposed to strangle Britain's maritime supply lines, began receiving monthly shipping loss statistics that revealed the mathematical impossibility of defeating American shipbuilding capacity through submarine warfare. American shipbuilding has achieved production rates that exceed our most optimistic pre-war intelligence estimates by factors of 4 or 5 to 1. We are sinking Allied vessels at rates that are historically unprecedented and strategically significant. But American replacement capacity is growing faster than our ability to inflict losses, even if we doubled or tripled our operational submarine fleet. The strategic implications were profound and ultimately decisive for the outcome of the Battle of the Atlantic. German submarine warfare, which had initially seemed capable of forcing Britain out of the war through systematic destruction of merchant shipping, was being defeated not by improved convoy protection or anti-submarine warfare techniques, but by American industrial capacity that could replace losses faster than German submarines could inflict them. The mathematics of naval warfare were being rewritten by American mass production methods that no European nation had anticipated, understood, or developed countermeasures against. Traditional naval strategy, based on assumptions about limited shipbuilding capacity and the difficulty of replacing major vessels, became obsolete when confronted with American industrial methods that treated ships like manufactured goods that could be produced continuously, rather than individual projects requiring years of skilled craftsmanship. By 1944, the statistical reality had become undeniable, even to German planners, who had initially dismissed American shipbuilding claims as obvious propaganda designed to maintain British morale during the darkest periods of submarine warfare. American yards were producing Liberty ships at rates that exceeded total German shipping losses from all causes, creating surplus merchant marine capacity that allowed Allied forces to conduct simultaneous operations in multiple theaters while maintaining adequate supply lines to Britain and the Soviet Union. The quality question that had dominated German assessments of American mass production methods was definitively resolved through practical experience as Liberty ships demonstrated their durability and reliability under the most demanding service conditions encountered in global warfare. While individual Liberty ships occasionally suffered structural failures, most notably the dramatic hull fractures that occurred in some early vessels during severe weather, the overall performance record proved that American mass production techniques could produce seaworthy vessels capable of surviving North Atlantic conditions, enemy action, and the demanding cargo handling requirements of military operations. Technical improvements implemented during production runs addressed initial problems and demonstrated American capacity for continuous improvement and quality enhancement within mass production systems that traditional European craftsmanship methods could not match for speed or effectiveness. Welding procedures were refined based on field experience and engineering analysis. Steel specifications were improved to prevent brittle fractures in cold weather conditions. Structural designs were modified to distribute stress more effectively under heavy loading and severe weather conditions. The result was a production system that successfully combined unprecedented construction speed with adequate reliability for military service requirements, creating capabilities that German experts had declared theoretically impossible based on centuries of European maritime experience and technical knowledge. Captain Felix Riesenberg Jr., a German-educated American merchant marine officer who served aboard Liberty ships throughout the war and possessed intimate knowledge of both American and European shipbuilding traditions, provided detailed professional assessments of Liberty ship performance that directly contradicted German predictions about mass-produced vessel quality and seaworthiness. These ships are not beautiful by traditional maritime standards, and they certainly lack the elegant lines and sophisticated engineering systems of peacetime cargo vessels designed for prestige service and passenger comfort, but they are remarkably effective at accomplishing their intended mission, carrying large quantities of cargo safely across dangerous waters despite enemy action and severe weather conditions. Riesenberg's analysis, based on extensive sea service aboard multiple Liberty ships, documented practical advantages of mass production construction that traditional shipbuilding methods could not provide. Their simple design makes them relatively easy to repair using standard equipment and materials available at any major port. Their standardized components allow maintenance and modification work to be performed by crews familiar with identical systems, rather than requiring specialists trained on unique installations. Most importantly, their robust construction philosophy tolerates battle damage and structural stress that would cripple more sophisticated vessels designed for peacetime service under ideal conditions. The strategic implications became increasingly clear as Liberty ship production enabled Allied military operations that would have been logistically impossible without massive cargo capacity available when and where it was needed most critically. The North African campaign, Italian invasion, D-Day landings and Pacific Island operations all depended absolutely on supply lines sustained by Liberty ships that carried everything from ammunition and fuel to food and medical supplies across oceans, where Axis submarines and aircraft maintained constant threats to Allied shipping. Liberty ships carried the 2,000 Sherman tanks that overwhelmed German armor defenses in Normandy, the aviation fuel that powered Allied bombing campaigns against German industrial targets, the food that sustained British civilian morale during the most dangerous periods of submarine warfare, the raw materials that kept Soviet factories producing weapons for the Eastern Front, and the supplies that supported American military operations across the Pacific Theater from Australia to the Aleutian Islands. Without Liberty ship cargo capacity, Allied victory would have been impossible regardless of American military courage, strategic planning excellence, or technological advantages in weapons and equipment. The war was ultimately won by logistics capacity rather than individual battles, and logistics capacity depended on merchant shipping that could be produced faster than enemy action could destroy it. By the war's end in 1945, the final production statistics told the story of the greatest shipbuilding achievement in maritime history and one of the most decisive industrial accomplishments in human civilization. 2,711 Liberty ships completed between 1941 and 1945, totaling over 27 million deadweight tons of cargo capacity, more shipping than had existed in the entire world before the war began. The average construction time of 42 days represented a revolution in shipbuilding that made traditional European methods seem antiquated and inefficient by comparison. Some ships were completed in fewer than 2 weeks, with the record-holding SS Robert E. Peary finished in an incredible 4 days and 15 hours from keel laying to launching. At peak production during 1943, American yards were launching Liberty ships at a rate faster than one per day, a pace that exceeded the combined shipbuilding capacity of every other maritime nation on Earth by margins that defied traditional understanding of industrial limitations. But the numbers represented more than just unprecedented industrial achievement. They demonstrated the decisive power of democratic societies to mobilize resources and human creativity on scales that authoritarian regimes could not match, despite their apparent advantages in central planning, resource allocation, and workforce control. The Liberty ship program proved conclusively that free people, properly motivated and organized, could accomplish industrial miracles that seemed impossible to professional experts and experienced observers who had based their assessments on historical precedent rather than democratic potential. The German spies who had dismissed American industrial claims as transparent fantasy found themselves documenting the reality of American abundance applied to maritime construction with methodical precision that made their earlier skepticism seem naive and professionally embarrassing. Oberst Heinrich Weber, whose pre-war assessments had significantly influenced German submarine strategy and resource allocation decisions, filed his final intelligence report from internment following his capture by American counterintelligence agents in San Francisco during 1943. American industrial capacity, when fully mobilized for war production, exceeds all previous examples in human history and challenges fundamental assumptions about what democratic societies can accomplish under existential pressure. They have successfully transformed shipbuilding from traditional craft industry, requiring years of specialized training, to mass production system that can be operated by workers with weeks of instruction. The Liberty ship program alone produces more cargo-carrying capacity each month than the entire German merchant marine possessed before the war began, and this production rate continues to accelerate rather than plateau, as might be expected from strained resources or worker fatigue. Weber's final assessment, written with the professional honesty that had made him a respected intelligence officer, acknowledged the complete failure of German strategic calculations regarding American industrial potential. We fundamentally misunderstood the nature of American society and its capacity for industrial transformation under wartime conditions. Our analyses were based on peacetime performance and traditional European approaches to manufacturing that bore no resemblance to American mass production capabilities when applied to maritime construction. The Liberty ship achievement represents not just quantitative success but qualitative revolution in shipbuilding that will influence naval construction for decades beyond this conflict's conclusion. The technological innovations pioneered during Liberty ship production indeed influenced maritime construction throughout the post-war period and established American leadership in advanced shipbuilding techniques that continued for generations. Welded construction methods, perfected under wartime pressure and continuous improvement processes, became standard practice for merchant vessels worldwide. Prefabrication techniques developed for rapid assembly were adapted for peacetime construction that emphasized efficiency and cost reduction over traditional craftsmanship aesthetics. The assembly line approaches that had seemed impossible to European maritime experts became foundations for modern shipbuilding that treated vessels as manufactured products rather than individual craft projects. Shipyards around the world adopted American organizational methods, worker training programs, and quality control procedures that had proven successful under the demanding conditions of wartime emergency production. Perhaps most importantly for long-term strategic implications, the Liberty ship program demonstrated that American industrial potential far exceeded peacetime appearances and could be rapidly mobilized when national survival required extraordinary effort and resource commitment. This lesson profoundly influenced Cold War planning, international relations, and American confidence in technological solutions to strategic challenges throughout the remainder of the 20th century and into the modern era. The men and women who built Liberty ships returned to peacetime occupations carrying with them skills, confidence, and understanding of American industrial potential that shaped their communities, families, and regional economies for multiple generations. The experience of participating in history's greatest shipbuilding achievement created lasting pride and technical knowledge that influenced career choices, business development, and community leadership throughout the post-war boom years. The shipyards that had produced Liberty ships became permanent centers of American industrial development, applying wartime techniques to civilian construction projects, naval vessel production, and offshore oil platform manufacturing that maintained American leadership in maritime engineering and heavy industrial construction. Richmond, California, Portland, Oregon, Baltimore, Maryland, and dozens of other communities retained shipbuilding capabilities that supported regional economic growth and provided employment for workers whose skills had been developed during wartime emergency production. Many former Liberty ship workers became entrepreneurs who established businesses based on technical skills and organizational knowledge gained during wartime shipyard employment. Welding contractors, steel fabrication companies, marine equipment suppliers, and industrial maintenance firms were founded by men and women whose expertise had been developed while building cargo ships under the pressure of wartime production schedules and quality requirements. The Liberty ships themselves served far beyond their intended wartime lifespan, carrying cargo in peacetime commerce, supporting humanitarian relief efforts during post-war reconstruction, and providing transportation capacity for American allies throughout the developing world during the early decades of the Cold War. Many vessels continued commercial service well into the 1970s and 1980s, testament to the structural durability of mass production construction methods that German experts had predicted would fail catastrophically under normal operating conditions. Some Liberty ships were converted to specialized uses that demonstrated their fundamental design flexibility and structural integrity. Grain storage vessels for emergency food reserves, floating hospitals for disaster relief operations, emergency housing for refugees and displaced persons, and even floating power plants for communities lacking adequate electrical infrastructure, all utilized Liberty ship hulls that had been designed for rapid wartime construction but proved adaptable for peacetime humanitarian and commercial applications. The strategic legacy of the Liberty ship program extended far beyond World War II to influence American naval policy, maritime commerce regulation, and industrial planning throughout the Cold War period and into the contemporary era. The demonstrated capacity to rapidly expand merchant marine capabilities became a permanent element of American strategic planning, with Liberty ship experience providing the foundation for emergency shipbuilding programs that could be activated during future national security crises. The National Defense Reserve Fleet, established after World War II, maintained hundreds of Liberty ships in preservation status as strategic reserves that could be reactivated quickly if international tensions required expanded shipping capacity for military or humanitarian purposes. These vessels, mothballed in protected harbors but maintained in potentially serviceable condition, represented insurance against future maritime emergencies that might require rapid expansion of American cargo carrying capabilities. During the Korean War, many Liberty ships were returned to active service, carrying supplies to United Nations forces and supporting the massive logistics requirements of modern military operations conducted thousands of miles from American industrial centers. The ships performed reliably despite years of inactivity, validating the durability of wartime construction methods and the wisdom of maintaining strategic shipping reserves. The Vietnam War again demonstrated the continuing value of Liberty ship design principles and construction techniques, as American forces required massive shipping capacity to sustain military operations in Southeast Asia, while simultaneously maintaining global commitments and alliance obligations in Europe and other theaters. Liberty ship experience provided the foundation for modern military sealift command operations that continue supporting American military deployments worldwide. The economic implications of Liberty ship construction extended far beyond immediate wartime requirements to influence American industrial development, international trade relationships, and maritime policy throughout the post-war period. The demonstration of American shipbuilding capacity established the United States as the world's dominant maritime industrial power and created export opportunities for American shipbuilding technology, equipment, and expertise. Allied nations that had witnessed American Liberty ship production sought to acquire similar capabilities through technology transfer agreements, licensing arrangements, and direct investment in American shipbuilding companies. British, Canadian, Australian, and other Allied shipyards adopted American welding techniques, prefabrication methods, and assembly line approaches that had proven successful during wartime emergency production. The international influence of American shipbuilding methods extended to former enemy nations during post-war reconstruction efforts, as Japan and Germany rebuilt their maritime industries using technologies and organizational approaches developed during American Liberty ship programs. The irony was profound. Nations that had initially dismissed American shipbuilding capabilities found themselves adopting American methods to rebuild their own war-damaged industrial infrastructure. The environmental and resource utilization lessons learned during Liberty ship construction influenced American industrial policy and manufacturing philosophy throughout the post-war period, though these implications were not fully understood until decades later when sustainability became a major concern for industrial planners and environmental advocates. Liberty ship production had required enormous quantities of raw materials, steel, aluminum, copper, rubber, and other strategic commodities that had to be extracted, processed, and fabricated using methods that prioritized production speed over resource conservation or environmental protection. The wartime emergency justified these approaches, but post-war analysis revealed both the potential and the costs of industrial mobilization on unprecedented scales. The experience of rapidly converting entire regional economies from agricultural or light industrial bases to heavy shipbuilding production provided valuable lessons about economic flexibility, workforce development, and community adaptation that influenced regional development policies and industrial planning throughout the remainder of the 20th century. The social transformations created by Liberty ship construction had lasting impacts on American society that extended far beyond immediate wartime requirements. The integration of women into industrial work, traditionally reserved for men, created permanent changes in employment patterns, gender role expectations, and family economic structures that influenced social development for generations. The movement of workers from rural areas to industrial centers accelerated urbanization trends and created new communities with diverse populations that had not existed before the war. These demographic changes influenced voting patterns, cultural development, and regional politics throughout the post-war period, and contributed to the broader social transformations that characterized American society during the 1950s and 1960s. The experience of working alongside people from different ethnic, regional, and social backgrounds in shipyards that emphasized production results over social conventions helped break down barriers and prejudices that had limited American social cohesion during the pre-war period. While full equality remained elusive, Liberty ship construction created opportunities for social interaction and mutual respect that contributed to the gradual advancement of civil rights and social justice. The technological spillover effects from Liberty ship construction influenced numerous other industries and contributed to American technological leadership in areas that seemed unrelated to shipbuilding but actually shared common technical challenges and solution approaches. Welding techniques developed for rapid ship assembly found applications in construction, automotive manufacturing, aerospace production, and pipeline installation that supported American economic growth throughout the post-war period. Material science advances required for Liberty ship steel production, corrosion resistance, and structural integrity under stress contributed to developments in metallurgy, chemical engineering, and manufacturing processes that benefited industries ranging from appliance production to nuclear reactor construction during the early decades of the atomic age. Quality control procedures developed for managing the consistency and reliability of mass-produced vessels became models for manufacturing excellence that influenced American industrial competitiveness in global markets throughout the remainder of the 20th century and established foundations for modern quality management systems still used in contemporary manufacturing. The management and organizational techniques developed during Liberty ship production, particularly the coordination of complex projects involving thousands of workers, hundreds of suppliers, and multiple simultaneous production lines, became fundamental elements of American project management expertise that influenced everything from interstate highway construction to space exploration programs. The Apollo program that put Americans on the moon utilized organizational methods, resource coordination techniques, and systematic approach to complex technical challenges that had been developed during Liberty ship construction 25 years earlier. The same systematic thinking that had enabled American shipyards to build cargo vessels faster than German submarines could sink them, ultimately enabled American aerospace engineers to accomplish President Kennedy's goal of landing men on the moon before the end of the 1960s. The cultural impact of Liberty ship construction became part of American national mythology and self-perception as a nation capable of accomplishing seemingly impossible tasks when circumstances required extraordinary effort and commitment. The image of American workers building ships faster than anyone had thought possible became a symbol of democratic determination and industrial capability that influenced American confidence in technological solutions to national challenges. Hollywood films, popular literature, and historical accounts celebrated Liberty Ship achievement as evidence of American ingenuity and determination, creating cultural narratives that emphasized the power of free people working together toward common goals. These stories, while sometimes simplified or romanticized, captured essential truths about American industrial capacity and social cohesion that had strategic implications during the Cold War confrontation with communist ideology. The educational legacy of Liberty Ship construction influenced American technical education, industrial training programs, and workforce development policies that emphasized practical skills, adaptability, and systematic problem-solving approaches over traditional academic or theoretical training. Community colleges, vocational schools, and industrial training programs adopted methods and curricula based on wartime experience that had successfully transformed inexperienced workers into skilled industrial craftsmen within weeks or months rather than years. The research and development implications of Liberty Ship construction established precedents for government-industry cooperation in technological development that influenced American innovation policy throughout the post-war period and created foundations for the military-industrial complex that supported American technological leadership during the Cold War and space age. The speed with which American industry had developed new shipbuilding techniques, solved technical problems, and implemented quality improvements demonstrated the effectiveness of combining government resources with private sector expertise and competitive motivation. This model became standard practice for major technological development programs, including jet aircraft, nuclear power, computer technology, and aerospace systems. The international diplomatic implications of Liberty Ship's success provided powerful evidence of American industrial capability that influenced alliance relationships, deterrence calculations, and strategic planning throughout the Cold War period. Allied nations that had witnessed American ability to produce merchant vessels at unprecedented rates understood that American military production potential far exceeded peacetime appearances and could be mobilized rapidly if international tensions required military preparation. Soviet planners, studying American Liberty Ship achievement, along with other wartime industrial accomplishments, concluded that direct military confrontation with American industrial capacity would be strategically disastrous and focused instead on asymmetric approaches, proxy conflicts, and ideological competition that avoided direct challenges to American manufacturing superiority. The demonstration that democratic societies could mobilize resources more effectively than authoritarian regimes when properly motivated became a cornerstone of American Cold War strategy and provided confidence for global commitments that required sustained industrial support over extended periods. The Liberty Ship example proved that American democracy was not a source of weakness in international competition, but rather a source of strength that could be activated when national survival required extraordinary effort. This incredible story of industrial triumph over expert skepticism demonstrates how democratic societies can accomplish the impossible when their survival depends on converting potential energy into productive action channeled through systematic organization and sustained commitment. The German spies who dismissed American shipbuilding claims as transparent fantasy witnessed the creation of the largest merchant fleet in maritime history, constructed in less time than traditional methods required for building individual vessels using conventional techniques. But this is just one of countless untold stories from this pivotal period in history that demonstrated American industrial might, democratic determination, and the power of free people working together toward common goals under existential pressure. What other shocking revelations await us in the archives of World War II? What other moments of technological achievement and industrial innovation shaped the course of history and continue to influence maritime commerce, military logistics, and manufacturing excellence today? If you found this story as remarkable as I did, I'd love to hear your thoughts in the comments below. What surprised you most about the Liberty Ship program and its complete transformation of German strategic calculations regarding submarine warfare effectiveness? Have you heard similar stories from your own family members who worked in wartime shipyards, served aboard Liberty ships, or witnessed the incredible transformation of American maritime industry during the war years. Your insights and family stories help bring these historical moments to life for all of us and preserve the memory of ordinary Americans who accomplished extraordinary things. And if you're hungry for more incredible stories like this one, make sure to subscribe and hit that notification bell. We're uncovering these hidden gems of history every single day, and trust me, you won't want to miss what we've discovered for tomorrow's episode. The story of how American factories went from manufacturing typewriters and sewing machines to producing machine guns and artillery overnight, and the remarkable woman who revolutionized weapons manufacturing using mass production techniques that even Henry Ford couldn't believe, will absolutely blow your mind. Until next time, keep questioning what you think you know about history, because the truth is often far more incredible than fiction, and the achievements of ordinary people under extraordinary circumstances continue to inspire us with examples of what becomes possible when freedom, determination, and industrial genius combine to overcome seemingly impossible challenges.